Problem 88. A flask contains two compartments, A and B, with equal volumes of solution separated by a semi-permeable membrane. Which diagram represents the final level of the liquids when A and B contain each of the following solutions? So here's the flask and the two compartments and the semi-permeable membrane, and you're putting these solutions on the left and those solutions on the right. Now this might look a little tricky. The way I teach it in the lecture videos is instead of these right here, imagine you have a U-shaped tube. It's open over here, it's open over there, but there's a little membrane right here. And if you pour one solution on the left and the same amount of another solution on the right, so the liquid levels are equal, what happens is water can flow through the membrane, but the solute particles cannot. And this is kind of like this right here. The idea behind osmotic pressure is water flows from the side that has a lower concentration to the side that has a higher concentration. So imagine that you put these two solutions, you put solution A on this side and solution B on that side, and suppose B is more concentrated, and this is less concentrated. So water is going to transfer to the more concentrated side in order to try and equalize the two concentrations. So as water goes to the right, that would make this less concentrated, and as water leaves this side going to the right, that would make this side more concentrated. And eventually the concentrations would be equal, and you'd be left with something like this, where water has just transferred. And it would stay like that. And vice versa would happen if A is more concentrated than B, then water would flow to the left, and it would settle down like that, which would look like this. So the pairs of solutions are given right here. The first one, A, you got 10% W over V glucose on the left versus 20% W over V glucose on the right. Water flows from lower to higher concentration. So it's going to flow from the lower concentration on the left over to the right. You're going to end up with this solution 2. And I got a typo here. This should say 2. Part B, you got 0.20 molarity sodium chloride on the left versus 0.30 molarity sodium chloride on the right. Now you might think this is lower concentration and it's going to flow towards that side, which is higher concentration, but remember, sodium chloride dissociates into sodium pluses and chloride minuses. For every 1 mole of sodium chloride, you got 2 moles of ions. And if you got 0.20 molarity sodium chloride, it's going to be 0.40 molarity of ions, because this stuff splits apart into its ions. So you got 0.40 molarity of ions versus 0.30 molarity of glucose molecules. Glucose doesn't dissociate. It's a molecular compound. So this is more concentrated, and water is going to flow from the right over to the left, and you're going to be left with situation 3. Part C. Part C and Part D are simple. Part C, you got pure water on the left versus 5% glucose on the right. So the water flows from the glucose over to the less concentrated water side, and you're going to be left with a situation. I'm sorry, from the less concentrated to the more concentrated, you're going to be left with situation 2. And again, part D, water is going to flow from the pure water over to the sodium chloride solution, and you're going to be left with situation 3. Last one, you got 3% sucrose versus 1% sucrose, so water is going to flow from the right to the left. From low concentration to high concentration, you'll be left with solution 3. That's osmotic pressure.